Hello everyone, welcome back to my YouTube channel. In today's video, we're going to be writing a pure Cairo program that model a coffee shop ordering system. So this video is specifically for the adult Kenya Stacknet base camp. I had a session with them, but because of the constraint in time, we couldn't finish up with implementations and all of that. So I needed to make this video, but anyone can as well learn from it. So the program is going to be a very basic one. We want to ensure that a customer can uh, place order for coffee, right? And then if that particular coffee is not available or ingredients for that particular coffee is not in stock, we should be able to provide meaningful feedback to customers, right? We uh, also need to track available ingredients in stock. So we need to track it because it gives the customer and even the uh, chef, right, information from the program. Yes. And then I think we can get started. The first thing that should come to mind, the very basic data structure that would come to mind is having an enum that has the coffee type with different variants. So it can have different coffee types. So I'm going to research and check out different coffee types that we have. Okay, let me just stick with the ones I know. Right. Okay, so we need to first make sure we have the derive uh, for the enum type to implement drop. So uh we want our value to be dropped after uh, when it's no longer needed in the program, right? Should be removed from memory. Coffee. Start the spelling of coffee. Coffee type. And we have Americano. I know espresso. I know espresso. So it and then this is quite common. Did I get the spelling correctly? Sino. Yeah. So another thing we want to ensure is that um, we want to ensure that um, um, our customers are able to order their different coffees in different sizes. So there should be a small, a medium, a large size coffee. Yes. So why is this throwing error? Okay. It needs a closing bracket. Yes. So we're going to define another enum. So let me just copy this so it will not make enum uh say coffee size. So we're going to have small, medium, large. Now, based on this coffee size, so when we want to calculate the price of that particular coffee, we'll have a specific price for Americano that has a small size, right? Or if it's medium or if it's large. So we'll be able to like calculate the prices based on the size of the coffee that is being requested for. Yeah. So another thing that we want to have is for ingredients. For ingredients, would need the basic ingredients for coffee. Search. There should be coffee, milk, or cream. Basic ingredient for coffee. I'm just searching. Coffee beans. I can see coffee beans and not water, of course. There should always be water. So we're going to just stick with coffee beans and milk, right? So we need to now create a struct. We need to create a struct that holds the coffee shop ingredients, right? Um, so the coffee shop. Okay, yeah. So we also can do the yes, and then we have struct and we create a struct. Yes, stock. So we have I want to type it for myself. We have milk, which is of U size. Let's say the milk will be in gram, of course. Let's say 32 should be fine. And then we have coffee, coffee beans. That could be caffeine, it could be anything, but let's just work with this. Let's use the same size as well. Um, Now um, we need to define our traits. So basically, um, traits are like interfaces. They're like interfaces in other programming language. So a trait defines a set of method that a type can implement. It allows different types to share common behavior by implementing the same method. So basically, you define your function without logic in the traits, and then you can implement uh, the methods later in your code. Um, so we have traits, um, price. So I'm going to go with price traits. So for price trait, the price trait is just basically to calculate the price. So, oh, sorry, function calculate price, and then uh we want to take this, uh take a reference coffee type. So basically what is happening here is that um, this self um, is used when the function is part of the trait information of the trait implementation for that particular type, right? So the trait for the type being implemented is coffee type. So how the trait how self works is that it's you can liken it to, okay, so self is a hen, you can be referred to as the coffee type instance, the instance of the coffee type the trait is being implemented for, right? That is why we're calling self uh, with the coffee type right here. So, and then we can have the size, because we also need the size to calculate the price, right? For a particular coffee type. So we do size and also take a reference. Yeah. So it's going to return you 32. Okay, coffee size, that's a mistake. Coffee size, yes. So you can think of it like saying self is like, this is the method, this is the method for this type, and then this parameter for size is like saying this is the data for the method to use. You understand? The major thing right here is coffee type, and then we need the parameter, the size, that to also determine the price for the coffee. So in this our coffee shop program, we're implementing price calculation for coffee types, right? And this size is just an additional information we need. That is why only coffee type uses self. So basically, in general, using self and art, if you've gone through the slide, you should already know what this art means. So the self, this it uses this art, right, to indicate that we are referencing the coffee type, we are referencing it, more like we are borrowing the coffee type, not taking ownership. So there's, you should already know what ownership is in Cairo, right? So we're not taking full ownership, we're just like borrowing it, we're taking a reference. Yeah. So let's implement our function. Let's implement our function. Uh, so when we want to implement, let me bring this down. When we want to implement functions in Cairo, we use impl. Is its full meaning is implementation, and it's just as similar with Rust, right? So we want to implement the coffee price implementation. So usually the convention is when you want to implement uh, a trait, right? You have the name and you put input too. It's just like a convention, right? Of price trait, yes. because that's what we want to implement. Why is it showing? No, I don't want to see you. Yes, so let's open this up, and then let me copy this function, paste it here. But right here, this is going to have the logic. So what do we want to now? We want to calculate price. We want to calculate price. So we have the coffee type and we have the coffee size. Now we want to calculate price for a particular coffee based on its size. So what we're going to do is to create a variable. We're going to create a variable and pattern match on the enum so we can get access to all the variants in the enum, and then we make our calculations. So let's do let base price of U32 uh, type equals to, we're going to match, oh sorry, so match is just like uh uh is just like you using a switch statement, so it can handle all possible cases of an enum, right? So we want to match on this coffee type, so we need to call the self, right, and open it so we can get access to coffee coffee type, and then you use column. As you can see, we have access to all. So Americano, we want to make it, let's say 30 bucks. Coffee type, uh coffee type, we want to make this 25. Coffee type, espresso, we want to make this 40. I'm not a coffee person, so I do not really know uh how expensive each of these coffees are. I mean, this is just a program. So let's say this is 20. It's going to cost 20 bucks. That's the base price. Now we need to also include fee as per the sizes. So we use do let size price equals to, what do? We match as well, and then we'll match using the size parameter so we can get access to the coffee size so size, open this up, then we have coffee size. Let's start from small. We want small to be 5. Coffee size, we want medium, to be 7. I'm just going to use prime numbers. And then coffee size large, we want it to be 9. Okay, and then close this up. Yes. So now what we just basically need to do is, if somebody wants a coffee type Americano of small size, we just say, hey, this is 30 bucks, but because it's more size, we want is going to be 35. So the cost of ingredient, we could say the cost of ingredient that it will cost is this, and then the service 5. I'm just saying. So we just do base price plus size price. Size price, and there we have it. We have the um, calculation for to calculate price. Now we need to uh, we need to also have an implementation to check the stock. It's very important that we track the stock to see is stock is milk actually available in stock to be able to make this coffee. Is coffee beans available to make this particular coffee? So we need to work on that. And because we do need to work on that, so we're going to be creating another trait, um, and we call it stock check trait. I mean, you can have everything in one place, but I just want to like separate concerns. So say if you're working on a very large code base, so you can organize your code properly. Yeah. So stock check traits. uh okay, we want to be able to check if something is in stock. And when we want to check if something is if a particular ingredient is in stock, we need to um, uh, check this stock struct, right? So what we're going to do is first uh, take a reference of um, coffee type, coffee type, right? Apart from that, add the parameter which is the stock. So we're also taking a reference of stock, right? And then we want it to in stock, it should return a boolean, either true or false, if that particular ingredient is in stock or not. So we also need, I think this is basically what we need. So let's head over to do the implementation. So we have, you already know, so we do stock check implementation, stock check info of stock check. Yeah, stock check, stock check traits. So now let's copy our function and then we open this. Now we need to, we're checking stock. So we need to get the um, what is beans available, is milk available. So what we do, um, is, since we are getting a reference of this, right? Okay, so let's bring out these variables. So beans is equals to stock dot coffee beans, right? And then let milk equals to stock dot milk, right? So we are storing them. Okay, we need to dereference these values that we are getting from the struct. Uh, the reason we need to do uh, this is because stock right here is a reference, of the struct, right? And because it's a reference, we need to get the actual value in stock. And what do we have in stock? We have beans and milk. So to get to dereference it, we use the um, this asterisk, the references, to get like the real value. Now we'll now be doing a match self. So um match self, we need to check if we have enough ingredients for that specific coffee, right? So we want our function to return either true or false based on the ingredient check. So now let's start with americano. So uh, coffee type, coffee type americano. Eh, what is happening? Oh, see me. Why did I come outside? This is so funny. Um, Let me just rewrite it because I don't even like how this came out. Okay. Um, yes. So we have, what am I writing? Coffee type Americano, right? So we want to check that, we want to ensure that Americano needs at least, um, hold up. Okay, let's say Americano need at least um 25 grams of coffee beans, uh, and then you need at least, right, 25 grams of coffee beans. We do Americano. Now that we have saved the beans, we have gotten the value, right? So this is what we use right here, beans, and then we'll make sure it needs at least, let me write it here, needs at least 25 gram of coffee beans. So we're going to do beans uh should be greater than or equal to 25 gram. We're just going to write 25, right? Why is my coffee type. Which one is the next? Um, use for this. Let's say it needs um at least 20 gram of coffee beans and 20 ml of milk. Needs at least 20 gram of coffee beans and around 80 ml of milk. So what do we do? Um, just do something of similar at least. So that's beans should be greater than or equals to 20. That's what we need. And where is my and milk should be greater than or equals to 20. We want to 80. We want to ensure that we have enough milk to process the order, right, for this. uh Coffee type, which one is the next? Espresso. We want to ensure that for espresso, let me just copy this. We want to ensure that the ingredient that this one needs is that it needs at least 20 gram of coffee beans, and let's just adjust the milk, 100 gram of milk. So it's just straightforward. Beans should be greater than or equal to 20 20 and uh milk milk 100 abi should be greater than or equal to 100, right? So for the last coffee type, we want the ingredient to have it could be um say um should we let it just have just beans? Should we let it just have just beans? Let me search for lactate, sorry, espresso. I need to be sure. Okay, seems espresso only needs beans. So what we need to do is let's copy this and use it to replicate for the last coffee type instead. So yes. So for espresso, we're going to just be using at least it should have 20 gram of this. Yes. So these are just random. And once we have done this, what's next? Um, Um, okay, so in a case whereby um, a customer places order and a particular coffee is not available, so we need to print needed item, needed ingredient in stock. So let's come to our stock check traits. Let's add one more function. You can just implement any function that you think works. So f uh, so needed ingredients, needed ingredients. So we're just going to self coffee, coffee type, and then I'm going to copy this. This is showing error. One thing that I forgot to mention is that when you're implementing trade, you have to implement all the methods in that particular trade. As you can see, this is showing error, and the reason why it's showing error is it's saying that not all trade items are implemented, missing needed ingredients. So we're going to be implementing needed ingredients now, and open. No more error. Okay, and so we since we it's a the coffee type pattern match again, match self, right, self. uh if we need the coffee type um of this, let us print print for americano we need 25 gram of coffee beans. So I'm just going to copy this, and so what's the next? This one should be the next. So for we need for cappuccino we need uh 20 gram 20 gram of coffee beans and 8 ml of milk. Yes. So the next one is the espresso. I think it should be espresso. For espresso, we need 20 gram of coffee beans, and finally yay, we need 20 gram, that if not available, 20 gram of coffee beans and 100 ml of milk. Okay, we have this implemented right here. So we need to create orders and process them. We need to create orders and process them. To create order, for a particular customer, we have their coffee type, right, and the size. So we need to have another struct. We need to have another struct. um this. So we need to create order, customer order, and then we have the coffee type. It needs to hold coffee type, and then the coffee type is of this coffee type, and then we need to also get the size. Size is the coffee size. Yes. So now we need a function to process order. Function to process order. um process order. So we are going to, okay, so process order, we are going to take the order, right, and then the parameter we need is talk at. So this order is taking ownership of this, is taking it into this process function. So it's not like the ones that we've been using self, that is passing a reference. This is taking ownership. So let's create order coffee. Let coffee equals to. So now that this our order, this process order is taking ownership of order. Remember, in Cairo there can only be one owner at a time. So this function is taking this process order function is taking the ownership of order. So we just need to take a reference of order right here, right, and then call the coffee type. Yes. ah Coffee. Yes. from the struct, right? So this creates a reference to the coffee type, right? Because our trait expect references. All the traits that we have, they expect references. So uh let's create other creator. Okay, so let's do if stock check traits in stock. Yes. What parameters does it need in stock? It needs the coffee type and stock. So we're going to pass in coffee type. Coffee, okay, is going to be coffee. So we'll pass in coffee straight in, right? We pass in coffee and then stock, and then stock. Yes. Stock, right? And then stock. So we'll calculate let price equals to, we want to call the price trait. Price trait, calculate price. So you can see the column is how we get access into those traits and all. Calculate price, and calculate price takes in the coffee type, and it takes in coffee and size. Yes, it takes in coffee and size. So what we do is the order the order has the coffee size in it. So basically what we do is we do uh, order dot size. Yes, we should be able to, yes, order dot size. Now once this price is been calculated, so we want to print that, print print your coffee is available, and then the total price is, then the price. We are going to test all of this out, right? We are going to test it out using the main function. Else we want to also have else print we are sorry, we don't have enough ingredients. Ew, we don't have enough ingredients for this coffee right now, right? And then so what we just do is to do stock traits needed ingredients, you get, and then pass in the coffee type, right? We are done with this particular function. So we need a function to uh test I think for this, so since once uh this calculate the price here, and if they check stock and this is not available, we print this, and um it print out needed ingredients, the coffee, uh the coffee with the coffee type, which is which can be any coffee type. So let's just try it out. Let's try out everything. So we need the main function to test out everything. Main, I don't like this. I don't want to see any output. Main, the main function. So let's say a customer wants to order for espresso. So we need to uh, check shop stock, stock, right? We have coffee beans. It should be giving me option now. So we first need to update the uh, stock, right? The stock, okay, milk and coffee beans. So milk, so let's say we are providing milk of up to 200 ml, 200 ml, and we are providing coffee beans up to um let's say 400 gram, right? That is very needed. So our customer can come after then to process order. So we have espresso, uh let's do customer order, customer one order. So we take the other struct. What does the other struct has? It has the coffee type and the size. So this particular customer wants, let me just, we have coffee type. This particular customer wants es- I think it should give me, I have no idea why it's not giving me. No, this is not what I want. Coffee type. The other has the other has coffee type. Don't confuse me. It is, oh, let me just type it out. Coffee type, right? And then we have coffee type of um let's say espresso. Yes, good. And then uh the size, the size is um the size is coffee size, right? Coffee size, let's say The customer wants a small size, a small size. So that this is the order. So we want to first tell the customer that yes, so we are printing your, we are processing your order, processing your order. Now to process order, we call the process order function. So just call the process order function, and the process order function takes in the order and the stock. Order is customer order, right? Customer order, and then, excuse me, the stock right here is shop stock. So we need to take, this is the actual stock, so we need to take a reference of that shop stock. And here we have it, and here we have it. So let's save, and then let's run. Control J. Yes, so let's run and see. Scab Cairo run. I expect it to so the customer order be successful because we have enough ingredients. Top stock, we have 200, 400. If you like, if you try it multiple times, uh, and it exceed the items, it's going to fail. So let's see what we have here. Yes, so we have processing your order, and then it say your coffee is available. Total price is 45. We should have made it that they should pay before service. But yes, yes. So we have come to the end of the video. Yes, and thank you for watching. Make sure you try this out on your own. So the exercise will be that you can add an ingredient, a particular ingredient. Maybe you can put sugar, yeah, and then edit accordingly. All right, see you in my next video. Bye.